begin by considering the differentiation of y is equals to ax raised to power n. Now, if you are given the function y is equals to ax raised to power n, we know that our dy dx is equals to an multiplied by x raised to power n minus 1. Let's consider some examples. So we have y is equals to 2x raised to power 3. Comparing it to ax raised to power n, we can say that our a is equals to 2 and our n is equals to 3. Therefore, our dy dx is equals to a n x raised to power n minus 1, where our a is 2, our n is 3. We have our x and our n, which is 3 minus 1. So our dy dx will be 2 times 3, that's 6x raised to power 3 minus 1, 2. Therefore, if y is 2x raised to power 3, then our dy dx is 6x squared. Let's take another example. Y is equal to 12x raised to power 3. Now we are comparing it to y is equals to ax raised to power n. Now we can see that our a is equals to 12 and our n is equals to 3. And we know that our differential format is an x raised to power n minus 1. Therefore, our dy dx is equals to a, that's 12 multiplied by 3 multiplied by x into 3 minus 1. And 12 by 3 is 36, is power x into 2. Next example, we have y is equal to 12 over x raised to power 3. Now we can change these into standard form because according to the law of indices, okay, we have that 1 over x raised to power n is equals to x raised to power minus n. Now y is equals to 12 over x raised to power 3 can be written as 12 multiplied by 1 over x raised to power 3. Now if you apply this principle to the conversion of 1 over x raised to power 3, we have this to give us 12 multiplied by x raised to power minus 3. And this will give us 12x raised to power minus 3. So if we have that y is equals to 12x raised to power minus 3, then our dy dx will be what? You can pause the video and try. Alright. So from here, comparing it to y is equals to ax raised to power n, we have that our a is 12 and our n is minus 3. Therefore, our dy dx is a, okay, dy dx has the answer of a and x raised to power minus 1. So that's equal to 12 multiplied by minus 3 multiplied by x into minus 3 minus 1. And this will give us minus 36 x raised to power minus 4. Okay, now you might want to rewrite it back in this format of x of 12 divided by x raised to power 3. Now we have this as minus 36 multiplied by x raised to power minus 4. Now if you reverse this principle and apply it to x raised to power minus 4, we have that this will give us minus 36 multiplied by 1 over x raised to power 4. And our dy dx, in conclusion, will give us minus 36 divided by x raised to power 4. Let's try another example. Y is equals to 3 root x. According to the law of indices, root x is equal to x raised to power half. Therefore, 3 root x is 3 multiplied by x raised to power half, and this will give us 3x raised to power half. Now, if y is 3x raised to power half, I want to evaluate the y dx. I want to try that. Pause the video. Now, comparing it to y is equals to ax raised to power n, we have that our a is equals to 3 and our n is equals to 1 over 2. And in this format, our dy dx is equal to an x raised to power n minus 1. Therefore, our dy dx is equals to a multiplied by n, that's 3 multiplied by 1 over 2, multiplied by x raised to power n, 1 over 2 minus 1. That will give us 3 over 2 x raised to power minus half. You can leave your answer like this, or you convert back. Let's try number 5. Y is equal to 6. If y is equals to 6, evaluate dy dx. Now, given y is equals to 6, how then can it doesn't have a function of x whatsoever. So, y is equals to 6 is the same thing as writing 6x raised to power 0, because anything raised to power 0 is 1. Okay, so this is written as 6 multiplied by 1, and which is the same thing as 6. So y is equals to 6 is also the same thing as writing 6x raised to power 0. So if you want to evaluate the differential of y is equals to 6, we are going to consider it as y is equals to 6x raised to power 0. Now let's compare it to y is equals to ax raised to power n, and our a is 6 and our n is 0. And we know the differential format of this is an x raised to power n minus 1. And now in this case, let's substitute. Then the y dx is equal to a, that is 6 multiplied by n, that is 0 multiplied by x into 0 minus 1. Now, since we have 0 to be one of the multiplicators, then our dy dx is equals to 0. Now, this brings us to a constant, or a theory, or a law, that if we differentiate, if y is equals to a constant can be any number from minus infinity to infinity, then our dy dx is equal to 0. Let's take another example. If y is equals to x minus 1 all squared. And to do this, we have to open the brackets. That's x minus 1 multiplied by x minus 1. And if we do this, we have x squared minus 2x plus 1. Now, to evaluate the differential of this, we are going to differentiate each of the terms from x squared to minus 2x and plus 1. So let's begin. So given y to be equals to x squared minus 2x plus 1, the y dx is equal to, now if you differentiate x squared, differentiating x squared, we assume this is 1, okay, that's 1 multiplied by x squared, so 1 is a and 2 is n, so this will give us 1 times 2 raised to the power x into 2 minus 1. And this will give us 2x raised to the power 1. That is 2x. So when we differentiate x squared, we have 2x minus. Now let's differentiate 2x. Differentiating 2x, we have this a to be 2 and our 1 to give us n. Okay, because x is the same thing as x raised to the power 1. Now this will give us 2 multiplied by 1, x raised to the power 1 minus 1. This will give us 2 into x raised to the power 0. Anything raised to the power 0 is 1. That's 2 multiplied by 1, and that will give us 2. Plus, now I want to differentiate a constant 1. And we can see from our previous example that if y is equals to a constant, then the y dx is automatically 0. Then the y dx of this is 0. So in conclusion, given y is equals to x squared minus 2x plus 1, our dy dx will give us 2x minus 2. So we can also have one last example. Given y is equals to 5x raised to the power 4 plus 4x minus 1 over 2x squared plus 1 over root x minus 3. Now the first thing to do is to put all the variables, okay, in the format of ax raised to the power n. Now y here will be equals 5x raised to the power 4 plus 4x minus 1 over 2 x raised to the power minus 2 plus 1 multiplied by x raised to the power minus 1 over 2 minus 3. Now we applied the principle of 1 over x raised to the power n is equal to 1 is equal to x raised to the power minus n. Okay, and x raised to the power root x here is the same thing as x raised to the power half. Alright, so let's simplify further as 5x raised to the power 4 plus 4x minus 1 over 2 x raised to the power minus 2 plus x raised to the power half minus 3. So if we differentiate each term, okay, differentiating each term, let's say each term, and then we have dy dx 5x raised to the power 4. When we differentiate this, we should have 20 x raised to the power 4 minus 3. 4 minus 1, that's 3. If we differentiate 4x, we'll have 4. If we differentiate 1 over 2 x raised to the power minus 2, we will have minus 1 x raised to the power minus 3. Okay, and if we differentiate x raised to power minus half, we'll have minus 1 over 2 x raised to power minus 3 over 2. And when we differentiate 3, we will have a constant. Okay, all is in the application of the law of y is equal, if y is equals to ax raised to power n, then dy dx is an x raised to power n minus 1. Okay, now let's have our final dy dx, which is the addition of all, calculation of all. So we have it to give us 20x raised to power 3 plus 4 minus into minus x raised to power minus 3. Remember the minus came from here, plus minus 1 over 2, x raised to the power minus 3 over 2 minus 0. Now this will give us 20x raised to the power 3 plus 4 plus x raised to the power minus 3 minus 1 over 2 x raised to the power minus 3 over 2 minus 0. In our next video, we'll be talking about how to differentiate the function of y is equals to sine in ax. Y is equals to sine ax.